Welcome back, Physics 30s. How's it going? So just going to go over this quick little 5-question assignment here. The chart is taking up most of the space here, so if I just delete the chart, probably be best, but I'll leave it there because we need the numbers. Calculate the speed of light in crown glass. Okay, so there's a few formulas that are not on your formula sheet, and this is one of them. So just remember that all these index of refraction numbers are essentially just a ratio between the speed of light and how fast the wave is traveling within there. I had to specify wave. There'll be a video later on where we talk about what is the speed of a particle of light. And it's always the speed of light, but when we talk about waves, it will slow down because of wave interference. So the speed, if I just rearrange that equation, is just going to be c divided by n. So c being the speed of light in a vacuum, so 3.0 times 10 to the 8 meters per second, divided by crown glass n. So I just find crown glass in here. I can find it. Oh, right there, 1.52. Crown glass, 1.52. So I divide by 1.52. Pretty simple calculation. Just remember that speed of light can never go faster than the speed of light in a vacuum. Or the speed of EMR, I should say. And this ends up being 1.97 times 10 to the 8 meters per second. There you go. Pretty good. Still pretty fast, but it slows down about 50%. A ray of light passes from air into water. So water is 1.33. It's one of those numbers you should know. And air is always 1.00. You can see up here, air is 1.000 with a 3 in it. Remember, we kind of just ignore that. We just go to the 3 sig digs. Vacuum 0, I'll say. But okay. What's the speed of light in water? Well, that's a kind of weird question because it really doesn't matter where the light came from. You're just going to be using this formula again. So 3 times 8 meters per second is going to divide it by 1.33. And it just ends up being the same. Same calculation, but it ends up being 2.26. 2.26 is 5.5, so it just rounds up to 8 meters per second. Yeah, so it didn't really matter where the light came from. So yeah, that's a useful indicator or a useful thing for a question on the test. Actually, it doesn't matter where the light came from. The property of the light will just be dependent on the material it's in. Light passes from crown glass again. So crown glass was, you said what did we have up there? 1.52. So I'm just going to put that here. Air being, that's air, I'm just going to put air beside it, 1.00. It refracts at an angle of 55. So they're telling us the angle as it enters into the material. So from crown glass, so let's just imagine, here's my boundary, crown glass, so from crown glass into air. So it's going to come out into the air. I'm going to assume it's going to refract out from the normal, and we have an angle of 55 here. Okay. Calculate the angle instance that struck the crown glass air boundary. So I want to find out what that data is there. So we're going to label these two sides. I'm going to call the top 1, bottom 2. That's going to be useful for my formula here. So sine theta 2, which I have, over sine theta 1, which I don't have. And then on this side, I'm going to have n2 on the bottom and n1 on the top. Okay, so we just put the pieces of information that we have in here. So we have the 55. So we put the 55 in there. Got sine theta 1, which we're trying to find, over, and then have 1.52 on the top and then 1 on the bottom. Okay. Yeah, okay, so let's go through. So we're going to go cross multiply. So we're going to go sine 55, make sure my calculator is in the right mode here. Divide by, times 1, divide by 1.52. Sorry, there's a weird dot there in the middle. Take the sine inverse. We get 32. Oh, yeah, 32.6. So after my cross multiply part, I'm just going to write the extra step in there. 5, 3, 8, 9, and then my cross multiply step here, or sorry, the sine inverse, I get 32.6 degrees. Yeah, so it did bend outwards. Okay, so in this one here, light passes from air into a diamond. So it's kind of going the other direction now. So here's my boundary. Here's my air. From air into a diamond. That's a diamond. I have to go back to the diamond. I don't have a diamond number, so that's a 2.42. Just wrote down the cloud glass number by accident. 2.42. So they want us to find out this angle. So it enters in at an angle of 15 degrees based on the wording, which it leaves the air boundary down, air diamond boundary. So I want to find this angle that's down here. It's angle 2. My situation. So I'm going to just put angle 2 on the top. I'm going to put 15 degrees on the bottom. And remember, these kind of reverse. So this is N2 on the bottom here. So it's going to be the 2.42. And it's going to be the 1 on the top. Okay, so we're going to do a cross multiply divide again. So sine 15 times 1 divided by 2.42. Take the sine inverse. And I get 6 degrees. So theta 2 equals 6 point. How many sig digs? The 3 sig digs. It has 1 decimal place, but let's go with the 3 sig digs here. 14 degrees. Okay, so what's the critical angle of this boundary here? So just remember when we do the critical angle of the boundary, that's when it's trying to leave the diamond itself. So we have an angle coming in here. Imagine this is the diamond down here. And then it refracts outwards here at such an angle that this angle is 90 degrees. So we're looking for this down here at the bottom. Okay. So let's just label this 1, let's label this 2. So I'm going to have to find sine theta 2, which is what I'm trying to find. Your sine 90, which we know is 1. If you know your sine or your unit circle. And then here I'm going to have N2 on the bottom again. So I think that works out. Yep. And then we have a 1 on the top here. Okay. So here we're just going to try to solve for that. So it's going to be sine 91, 1 over 2.42. Take the sine inverse, and we get an angle of, a critical angle of 24.4 degrees. There we go. Hopefully that wasn't too bad. Hopefully it was pretty easy. And I'll see you in the next video. Bye.